Let's understand reliability and validity with a simple situation. Imagine a digital blood pressure monitor in a clinic. You measure a patient's blood pressure 3 times. The readings are 150 by 95, 150 by 95, and 150 by 95. But when the same patient is measured using a well-calibrated device, the actual blood pressure is 130 by 85. What does this tell us? The previous machine is consistent in its reading, but the reading is not accurate. So the instrument is reliable but not valid. Reliability refers to the consistency or repeatability of a measurement, and we define reliability as the degree of consistency or repeatability of measurements when they are repeated under identical conditions. In simple terms, reliability answers the question, will we get the same results if we measure again? Now that you understood the concept of reliability, you can see that reliability alone isn't enough. As we saw with the blood pressure monitor, the measurement can be consistent and still be wrong. This brings us to the second concept of validity. Validity refers to the accuracy or truthfulness of a measurement. It tells us whether the measurement actually reflects the real value of what we intend to measure. We define this as the degree to which a measurement actually measures what is intended to measure. In simple terms, validity answers the question, are we measuring the right thing? And in diagnostic testing, we often interpret this as, are the results actually true? Now that you understood reliability and validity, there is an important relationship between the two. Reliability is necessary for validity, but reliability alone does not guarantee validity. I hope you get the clarity that a measurement can be reliable without being valid, like we saw with the blood pressure monitor. But our measurement cannot be valid without being reliable. Because if the measurement is not reliable or consistent, it cannot accurately represent the true value. Look at it this way. A broken clock always is showing 3 o'clock. It's perfectly reliable but not valid. Another way to understand the concept of reliability and validity, which I'm sure you must have come across before, is using a target board. Imagine arrows hitting a target. If the arrows cluster tightly together but far from the center, the measurement is reliable but not valid. And if the arrows are scattered everywhere, the measurement is neither reliable nor valid. If the arrows cluster tightly at the center, the measurement is both reliable and valid. Now let's quickly recall what we learned so far. Reliability means consistency of measurement. Validity means accuracy of measurement. Reliable measurements can still be wrong, but valid measurements must first be reliable. Understanding these differences are essential for the interpretation and evaluation of research and scientific findings. Finally, let's test our learning with some self-evaluation questions. Question 1. A weighing scale gives the same reading every time but differs from the true weight. Is the measurement reliable or valid? The correct answer here is reliable but not valid. The second question is, a woman suspects she may be pregnant and performs a home urine pregnancy test 3 times on the same day. All 3 tests show negative results. 2 days later, a blood test confirms that she is actually pregnant. Which of the following best describes the pregnancy test kit in the situation? The correct answer is reliable but not valid. And the last question is, a measurement cannot be valid unless it is. The correct answer is reliable. I hope you understood the concept of reliability and validity through this video, and I'll see you in the next one.